Welcome all. In this video, I would like to demonstrate on how to analyze and design a residential building, provided you have the architectural plan with all the section details, elevation available with you. So let us see how step by step you're going to proceed in analysis and design. And to do this, I'll be using STAAD software. Now, any building design would require first an architectural plan. So the residential building which I have is a G plus 3 building, and in the ground floor, as you can see here, you have parking space, while the first to third floor are typical, mean whatever is the plan in the first floor, same is for the second, and same goes for the third floor also. So this is the plan. Now, in order to see the floor height and the location of the plinth level from ground level, and all these details you can get if you have a section, and you can see one section A has been cut over here. And also you can see there is one more section BB which has been cut here. So basically these sections have been provided in order to show the maximum details. Like here, if I see section A, I get the detail for the staircase as well as the left room. And also it gives me an idea regarding what is the height of the building, total height of the building. And you can see the plinth level from the road level is at a height of 150 mm. And if I see section BB, from section BB you can get the floor to floor height, and also here in the toilet area you can see there is a provision of sunken floor. So all these details you should have before you should go ahead with the analysis and design for this particular problem. Question is, what do you mean by these analysis and design? Basically, what you will try to do, will try to proportion the column dimensions or whatever column dimensions which architect have provided. For that, one have to tell what should be the total reinforcement which needs to be provided in the column. And also you need to design slab, you need to design staircase, you need to design roof beams at different floor levels. Then you have to design the footings also. So all those the design one need to do. But before designing, thing is you have to analyze the structure for the possible loads which is going to act in your building. Now, what I will do for my demonstration, I'll be using National Building Code 2016. So probably you get a copy of this NBC 2016 and start referring along with me whenever I direct you to do so. So let us begin. So first what I will do, I will uh, give the description of the building. What is the details of the building? It's like I want to know the length of the building, breadth of the building, what is the parking area, height above ground level. So all these details I'm going to write down first. So let me consider this as the length of the building, which is 21.68 meter, and this as the width of the building, which is 6.6 meters. So length of the building I'm considering as 21.68 meter. What about the breadth of the building? As you can see, it is 6.6 meter. 6.6 meter. What is the parking area height above ground level or from the road level? It was 150 mm, so 0.15 meter. And what should be the possible foundation depth below ground level? So let me say the foundation depth which I'm going to provide is 2.1 meter. What is the height of each floor? To know the height of each floor, you need to refer the section. It is 2.85 meter. 2.85 meter. Number of floors, how many floors you have? So it's a G plus 3 building, so how many floors you have? You have 4 floors. What is the staircase headroom size? Now, in order to know the staircase headroom size, you can see here is the headroom. This is the headroom which you have. Now, from the section itself, if you want, you can measure the outer dimension. It's coming 6.6 meter. Okay. Or what you can do, you can measure the inside dimension. This is the headroom. It's coming 6.12 meter, and here also the headroom size. It is 6.12 meter by 2.65 meter. So the headroom size for this is 6.12 by 2.65 meter. Location of building, let us say this building is located in Ranchi. The grade of concrete which I intend to use is of M25 grade, and the yield stress of steel or the grade of steel which I'll use is of Fe415. It means not, let us say Fe500, and it means the yield stress is going to be 500 Newton per millimeter square. So this is the details of the building for which I will try to design. So to start with, let us discuss first regarding the plinth beam. Nowadays, most of the engineers are providing plinth beam at ground level. The idea of providing plinth beam at ground floor level is to support wall up to roof level. There are some structural advantages in providing plinth beam at ground level, like say for example, this is the ground floor plan, and if I see the section over here, okay. Now I know the column at 2 point till 2.1 meter depth, this column is going to go down. Now, if you are not providing any plinth beam at this particular location, it will mean that the column height is going to be 2.1 plus this 2.85 meter. So the column length is going to be very large. So you are going to have a very large unsupported length of the column, which is going to require more amount of steel, or the cross section size is going to increase. Now, to avoid this, you provide plinth beam at the ground level at this particular level, or this particular level, you are going to provide the plinth beam so that it decreases the unsupported length of the column. Thereby, it will increase the capacity of column against buckling, and also it is going to decrease the movement in support, and ultimately it is going to result in economy in design of column as well as foundation design. To start with, first thing it comes, like when you see this plan, you have to locate the columns. Okay, you need to locate the column. In this architectural plan, the architect has given the location of the columns, and we would like to first see whether these position of the columns is going to be fine for my case or not. As you can see, the spacing between the column is 6.12 meter. Please understand, if the spacing between the column is very high, it will require more depth of the beam. Okay, because in order to control the deflection in the beam, you need to have more depth in the beam. Most of the time, one should try to keep the column spacing within 3 to 5 meter, but here you do not have any option of reducing the spacing between the column, because as you can see in the ground floor area you have a parking area, and in case if you provide a column here, it is going to restrict the movement of the vehicle, so that is not actually feasible. So that's why here the columns at a column spacing of 6.12 meter, you have to design these columns. So we have the location of these columns and the dimensions of the column, which is given over here for the design, which has been specified. As you can see, it is 480 by 240. So the column dimensions which is been specified to me is 240 by 440. So let me write down the geometric properties. So first I'm having column. It is having a dimension of how much? We had seen it is 240 mm by 480 mm. As I said, you are going to provide a plinth beam at ground floor level in order to support the walls on the ground floor. So, what would be the plinth beam dimension? So, plinth beam. So, the plinth beam which I am going to prefer is going to be having the width of 240 mm with the depth, say, I'll provide it as 420 mm. Okay. What about roof beams? So the roof beam which I will be preferring is 240 mm by say 450 mm. And please see this 450 mm. It is going to include the thickness of the slab also. Once you have these plans, I recommend you draw the column layout, plinth beam layout, and the roof beam layout. Now for this, what I have done, I have drawn the column layout, as you can see. This is the column layout and I have given the grid location. This is my grid A, grid B. Say if I want to design this column, I can always refer this column as A1. A1 means the column which is lying in the intersection of grid A and grid 1. Similarly, when I talk about this column can be referred as column B1. Okay. So I have marked the grids. So these grids are indicating the center line of the column. Okay. And many times what you'll find that some of the columns are not going to pass through exactly the center. Like if I see here grid number 2. In grid number 2, one of the column is passing through the center line, but the other column is not having the same center line as the grid 2. So I need to mark by how much it is deviating. Okay, from the center line. Why I'm doing this? I'm doing this because when I try to model this, I will be needing this data. Okay, when I orient my column, when I'm going to orient my column in my STAAD modeling, there I will be giving some offset of 120 mm with reference to this column. We'll see that. So the first step, what you need to do is to make a column center line drawing by indicating the grid line. And suppose if any of the column is not intersecting with the center line of the column, you specify, okay, you specify by how much that column is deviating from the center line. Okay. As I said, you provide plinth beam to reduce the unsupported length of the column. So say if I go with this column, what I'm doing, I'm providing plinth beam on both the directions. So obviously the unsupported length of the column about both the axes is going to reduce. Okay. So just by looking into the wall location as well as uh, the feasibility of breaking the unsupported length of the column, you have to provide the plinth beam. So this is one of the possibility of going with the plinth beam layout. Okay, so this is the plinth beam layout. Next, what I did, I made the roof beam layout from first to third floor. So wherever wall was there, okay, wherever wall was present, there I have provided the beam. Okay, so you can see, for example, if I see over here, like here, so what I did here, I have provided a beam, and here also I have provided a beam, and here also I have provided a beam. So you can see same thing over here. Okay, you can see same thing over here. If you observe, there is one balcony which is 1.02 meter wide. So to support that 1.02 meter wide balcony, here there is a periphery beam which is 200 mm wide. Okay, so this is 200 mm wide, and the depth which I'll be providing is going to be same as 450 mm. So once you complete this, actually we are ready for the geometric modeling in STAAD. So let us see how you can do the geometric modeling in STAAD.